This is Devansha from LG Institute of Engineering and Technology. Today, let's start and discuss about the basic component of electrical circuitry. There are three basic components of electrical circuitry. It's called resistance, inductor, and capacitor. So, in our primary things like to survive in this world, we required a roti kapda makan. Same way, to design electrical circuitry, we required resistance, inductor, and capacitor. So if you see, there are various home appliances like you have a microwave oven, television, fridge, and washing machine. All circuitry or all home appliances you can use because of the resistance, inductor, capacitor. Now, why this is very important? Because to make this kind of home appliances at the scratch level, you require electrical circuitry. Now this electrical circuitry is made up of resistance, inductor, and capacitor. So all these home appliances are operated on this electrical because of this electrical circuitry, where it consists of resistance, inductor, and capacitor. So that's why these are the primary components. Yeah. Now what we are going to do here, we are going to take resistance, inductor, and capacitor and in a circuitry as a part of the circuit element, and then we have to apply AC circuits or we have to apply AC voltage or a DC voltage. So ultimately in this unit we are learning about the DC circuit. So this particular resistance now we are going to connect in a circuit, and then we apply DC voltage across this resistance. So here you need to check, once you connect resistance, inductor, and capacitor under the DC biasing condition or under the DC excitation condition, you need to check the behavior of resistance, inductor, and capacitor. So in our first section, let's start and check the behavior of resistance under the DC excitation. So that's why you can see here one of the circuit where resistance is only the element in the circuit, and you apply the DC battery, a DC voltage. So once the current is going across this resistance, how it's going to behave under this condition, you can check here. So these are the basic components, how it looks like in a market. Once you connect this components, these elements in a circuit, it's look like resistance, inductor, and capacitor. These are the symbols of resistance, inductor, and capacitor, and these are the units of resistance, inductor, and capacitor. So the unit of resistance is ohm, unit of inductor is Henry, and unit of capacitor is Farad. Right now, once you see this here, once you see this, resistance is a passive element. Once it's like you apply a voltage, it will simply drop the voltage, but not this is the case with inductor and capacitor. Once you apply the voltage to inductor or capacitor, it has a phenomena to charge and discharge. So ultimately capacitor and inductor are working with respect to time. So ultimately this will give you a response with respect to time. Now resistance has a symbol, and it's a unit at ohm, and unit is ohm, and you can see once you go to market and buy the resistance, it will look like this way. Now you can use this resistance as a circuit element. Now what's the use of this resistance? You require this resistance because of the voltage drop in the circuit, and because of it also regulates the current. So ultimately this resistance will give you two important fundamental functions. One is it have a voltage drop, and another, it will flow the current through it. Because of the flow of current through it, you can regulate the flow of current. So these two important functions are very useful to design a circuit. So here our ultimate aim is to design the circuit for those kind of home appliances that we can use for the society. So for the society. So ultimately you have to use the resistance to have a voltage drop, and that particular voltage drop will drive your home appliances. And as well as if you want to control the operation of your home appliances, you need to control the value of current, and that is also possible through the by the value of resistance, or by proper choosing the value of resistance, right? So here you can see how you can use those kind of resistance in a PCB or in a circuit diagram. You can see these images. Now, once you go in the market and you want to buy a resistance, see this particular resistance is available in this form. So you can see the image. This particular resistance is available in a market. But once you go and once you go and ask anybody, I want a resistance. It's not simply you can get the resistance, but you have to tell the value of resistance, and that particular value based on the physical structure of this resistance. So if for anything, any object, it must have the value of resistance, and that depends on its used material and shape of this object. So here you can say the resistance is proportional to the length of this object, as well as the resistance is inversely proportional to the area of this object. So ultimately R is proportional to L and R is inversely proportional to area. By that way, if you solve this equation, you will find R is equal to rho L by A. So ultimately R is proportional to L, R is inversely proportional to area, so R is proportional to 1 by area. So once you solve this two equation, you will find R is equal to rho L by A, where L is the length in meter, area A is area in meter square, and rho is called the resistivity. Now this is a very important parameter, because resistivity is nothing but the property of the material that can decide whether this particular object has how much that particular object is offering how much resistance. So resistivity, if you convert this particular equation R is equal to rho L by A in terms of the resistivity, you will have rho is equal to R into A divided by L. So ultimately the unit of this resistivity is called ohm into meter, right? But in real world, you need to understand that particular term as well, and that particular term if you define, where it's called the reciprocal of resistance is called a conductance. So we define here conductance as G, and the unit of conductance is mho, or 1 by ohm, right? So ultimately from the resistivity you can also define the conductivity. So conductivity is nothing but the reciprocal of resistivity, right? So it is ohm by meter. And based on this conductivity, you can now categorize all the materials in three forms, or it's a type of three forms. One is called conductor, another one is called insulator, and third one is called semiconductor. So based on this conductivity, now you can categorize those kind of material, and based on this material you can use your you can further use this material based on the resistivity or offered conductivity. Now, let's say we enough talked about the resistance. Now let us discuss about the capacitor. So this is the symbol of capacitor. The unit of capacitor is in farad, right? How it looks like once you go to the market and you want to buy the capacitor, it's look like this way, right? And if you want to use those capacitor in a circuit, you can see the following images, right? Now, what are the different functions of capacitors? So ultimately, what is the function of capacitor? Why we use a capacitor? So capacitor we use to store the energy in form of charge, and that charge Q is equal to C into V, right? So ultimately, it is not a straightforward element. Why? Because it also changes the behavior with respect to time. So ultimately, once you use this capacitor, you will have rate of change of voltage with respect to time. So ultimately, this will give you a most important terminology, which is called dV by dt, and that particular dV by dt we are going to use for the analysis of time domain RC or RL circuitry, right? Now, so far our next component is called inductor. So this is a symbol of inductor. This is a unit is in Henry, and once you go to market and you can find this kind of inductors, it looks like this way. And if you want to use in a circuitry, you can see all the components you can use in a PCBs, right? Now, what are the functionality of inductor? So ultimately, capacitor and inductor both will store the energy, but capacitor will store the energy in form of charge, but here inductor will store the energy in form of magnetic field. So ultimately, once we apply the current to the inductor, it will produce magnetic flux around it, and that particular flux is nothing but a kind of magnetic field which is being stored in a inductor. So ultimately, whatever here current you apply, that particular current you will find the variation with respect to time. So this particular inductor would give you a component, very effective factor, that is called di by dt. So this the capacitor will give you dv by dt, and inductor will give you di by dt. That those two particular terminology we are going to use in our further circuitry, right? Now, same way, we forgot to discuss in a capacitor, like energy stored in a capacitor, W is equal to 1 half Cv square, while energy stored in inductor, E is equal to 1 half L square. So ultimately, 1 half Li square. So ultimately, capacitor and inductor, right, both will behave with respect to time of variation, with the time or rate of change with the time. So ultimately, here the capacitor would give you, actually once you connect the capacitor in any circuitry and once you apply the DC, that means the voltage drop across capacitor, that particular charge is nothing but is going to oppose the applied voltage. So these two important factors is very essential to analyze any circuit or to design any circuit, which is dv by dt and di by dt, right? So this is different sources you have to connect with the circuit. Let's say some of the DC voltage source and currents, you can see here there are symbols of the DC voltage source and DC current source, right? Same way you have a AC voltage and AC current source, where you can see here the symbols of AC voltage source and AC current source, right? Now, again, there are various part of the sources, that some of the sources are independent sources, right? So these independent sources are defined as here as a part of symbol, and some sources are dependent sources, that sources itself depend on some other sources, we can define as a dependent sources. So these are nothing but various components, various elements that can be involved in a circuit design. Thank you very much, students. If you have any doubt, you can discuss below comments. Thank you very much. Thanks for your